Okay, so one of our topics is improper integrals, which is basically when you have an integral on an interval that is like from a number to infinity or negative infinity to a number, obviously. So anyway, so basically what you're going to have to do is change it so that you have a limit rather than just the integral itself. So I'll do an example and I'll just walk you through it. So I'll use the example of 1 to infinity of 1 over x squared. And then what we can do from here is, since we don't really know how to use infinity as a limit of integration, we can change it to a variable such as x, t, and whatever letter you want. And then what we can do is have a limit as x approaches that the limit up here, which is infinity, or if we had negative infinity down here, we could do the same thing. So what we do from here is we're going to say limit, I'll use t approaches infinity. And then what we can do is now we can substitute t for infinity. So 1 to t of 1 over x squared dx. And then what we can do from there is we can kind of ignore this and integrate this side. So what we can do is have limit t approaches infinity. And then in here, what we're going to do is we're going to integrate 1 to t of x to the negative 2 dx. All I did was I took this and put it in terms of x instead of putting it on the bottom. And then from here, we know how to integrate this. 1 to t of, this is going to be, since it's x to negative 2, it's going to be 1 over t. And then what we can do is we just plug in t, we're going to integrate. So limit as t approaches infinity is going to be, negative 1 over t. We're just normally integrating this minus negative 1 over 1, which equals, limit as t approaches infinity. 1 minus, all I'm doing is simplifying this, 1 minus 1 over t. And then as we can see here, if t were to approach infinity, we can put infinity on the bottom, just think about it that way. 1 over infinity is going to be practically 0 because infinity is such a huge number, it's going to be infinitely small. So if we have 1 minus infinitely small, it's going to be 1. So our limit is going to equal 1. And what we can say about this is that the integral here that we started with equals 1. And basically what we're going to say is it's convergent because although it's an infinite area, it's going to converge to a constant number. But functions aren't going to do this. A lot of them will approach infinity